exam ready, achieve top grades. Welcome to this lesson on Surds Part 3. Today we're going to be applying Surds to area, series, and trigonometry. Let's look at those aims in detail. What you will master today in Surds Part 3. So the first objective is find the shapes of area. We're going to work out areas of rectangles, triangles, and squares with third dimensions. Secondly, we're going to work with geometric series. And here we're going to find terms and sums of geometric sequences with a third common ratio. And finally, we're going to apply exact trig values. This means we're going to use exact sine, cosine, and tan values in third form to solve triangle problems. So this is a recap from the first episode. So I would suggest that you go and view the first one, where we actually discuss this in more details. But anyway, I'm going to just very quickly recap on that one. So this one is when you multiply surds together. That one is for the division of surds. This is when we are squaring surds. And finally, this is for addition or subtraction of surds. Now, let's move on to area of shapes with surds. You will notice that in the question, when we are working out the area of shapes, we are required to, after finding the area of shape, simplify the surd as well, wherever relevant. Now, in order to work out the area of a rectangle, the formula is length times width. So here's our length, represented by letter L in our formula, and width represented by letter W in our formula. So we got square root of 12 multiplied by square root of 3. That gives us square root of 36. And that simplifies to 6. And don't forget the unit, and that would be centimeter squared. And here's your answer. Moving on to the next question, we got to work out the area of a triangle here. So area of triangle, if you remember the formula, it goes like this. So it's base multiplied by height divided by 2. So we got the base letter B and the height letter H. So let's multiply them together and halve that. So we're going to get 4 square root of 2 multiplied by 3 square root of 2, and then we divide this by 2. Now you will notice that you're going to get 4 divided by 2. Now 2 is common in both numbers, so 2 in 4 is 1, 2 in 2 is 1. And then we're going to multiply the rest. So root 2 times root 2 is going to give me 2, and then you got 1 times 3, and that gives me 3. So that's going to be 3 times 2 over 1, and that gives me 6 centimeter squared as the area of the triangle. Next, question 3 is about the area of a square. So area of a square is simply length multiplied by length. And we got the length here, which is 2 plus root 3, and then multiply by 2 plus root 3 again. Okay, so our first set of multiplications, there we go. So 2 times 2 will give me 2. 2 times plus root 3 is going to give me plus 2 root 3. Then the second one is going to be 2 times root 3 again. So that's going to be 2 root 3. And then root 3 times root 3. So we are squaring a third, and that will end up giving me just a number. Okay, so we are moving on, and don't forget the equal signs. So 2 plus 3, we're collecting like terms, it's just numbers here. 2 plus 3, sorry, is 5, and then collecting like surds. So we got 2 plus 2, and that gives me 4. Therefore, 4 root 3, and all of that is centimeters squared. And don't forget the unit again, so centimeters squared, and that's our answer. Now, you're going to have some practice questions over here on the right-hand side, and let's go for it. So here we go. Similar questions which you can do if you want to compare with the left-hand side. Okay, I'll see you on the next slide. You can pause here. So here are the answers. Okay, and I think you should be getting them all right by now. This is our final part of this session, geometric series with surds. And what we got to do is find a term or find the sum of terms. So here we go. Now, if you remember, when we started, the geometric series is A followed by AR squared, AR cubed, and so on. So this is term 1, term 2, term 3, term 4, and so on. So A is the first term. Just as a reminder, first term is A. And common ratio, we use the term common ratio to refer to the multiplier. So the common ratio is R. So what we do is we multiply by R, multiply by R, multiply by R. So this is going to be a constant multiplier to generate the next term. Now, in the first question, geometric sequence has first term A, which is 3. And the common ratio, R, is root 2. Okay, so we are looking for the third term. So to get the third term, as you can see here, so the third term is equal to AR squared. Okay, I could have written T3 to represent the third term, and I just have to substitute, like in a formula, substitute the values for A and R. So as we can see, A is 3. Let's do the substitution here. R is square root of 2, and that is squared. So that is equal to 3. Now, square of a square root cancel out. So we simply have to multiply 3 and 2 together. So sorry, that is a mistake here. So that's 3 times 2, and therefore that is equal to 6. So this is our third term. Now, may I just remind you that in exam, when you write the number wrong, you need to cross the number, like what happened here. You cross the number and you write the correct number on top. You do not do this and then just write 2 on above that. You overwrite. Yeah, that is a no. That is correct way of doing it. So a geometric sequence has, that's the next question. So geometric sequence has first term 2. So that is our A. And the common ratio is root 3 R. Sorry. So fourth term, now you can see our fourth term is AR cubed. It might be useful to write this sequence in your exam, on your exam paper, when you are attempting that type of question. That way you won't making any mistake. So T4 is equal to AR cubed. So A is 2, R is root 3, and that is cubed. If you want to, you can write it as 2 multiplied by root 3, multiplied by root 3, multiplied by root 3 before you simplify. Okay, so these two will give me just 3. So therefore you have 2 times 3, which is 6. 6 multiplied by root 3, So that is 6 root 3. And that is our answer for question 2. Now, question 3. The first term of a geometric sequence is root 5. So that is our A. Then the common ratio is root 5. Now, in this case, we're going to have to work out the sum of first 3 terms. Now, as you can see over here, we're going to add T1 to T2 to T3 to get the sum. So the sum of the first 3 terms is T1 plus T2 plus T3. If you want to, you can write A plus AR plus AR squared. What is A? A is root 5 plus then you have root 5 multiplied by root 5 plus root 5 multiplied by root 5 squared. So that gives me root 5. So squaring root gives me just the 5, and that one is going to give me, that square cancels out the square root, so that gives me just 5, and that gives me 5 root 5. And the final answer now is, if we collect like terms, so these two are like terms, like surds, so you're going to have 5 plus, remember that is an invisible 1 here, 1 plus 5, that's 6 root 5. Okay, so that's the answer to this question. Now, we are now going to practice, or rather it will be you practicing on this side of that slide, and here you are. So have a look at the questions and the way I have gone through this on the left-hand side, and you can do it by yourself on the right-hand side. So I'll see you on the next slide for you to compare your answers with mine. I hope you have been able to work it out, all these questions, question 1 to question 3. And now let's move on to the next part of this is our final section, which is called the special angles in surd form. Now, you will have to memorize the surd form of some trigonometric values. Okay, so we are talking about here the values for special angles only. Now, those special angles are indicated in the first row. So the value of theta, for example, 0, 30, 45, 60, and 90 are known as special angles here. And we're going to be looking at the values for the sine values, cos, and tan values for each of these special angles. You can actually generate your table by yourself, and I'll give you a simple trick. So we're going to start with 0 on top of the table. Imagine you haven't got any of those values in the table other than 0, 30, 45, 60, and 90. So we're going to start with 0, 1, 2, 3, and 4. Each of these values, divide them by 4. And then you take the square root of all these fractions, as you can see here. So you're going to take the fraction, and then you're going to take the square root of each of them. Now, if you simplify these, 0 divided by 4, 0 divided by any number equals to 0. That's what you're going to get for sine. Now, square root of 1 over 4 is the same as the square root of 1 over the square root of 4, which gives you 1 over 2. And as you can see, it's just that value in the sine row. That one will end up with a square root of 2, and then square root of 4 is going to give you a 2, and so that's root 2 over 2, which gives you the next value for sine. So for 60 degrees, you will have the surd, which is root 3, and square root of 4, which gives you 2, and again, you have that value there. And that one, 4 divided by 4 is simply 1, and square root of 1 is going to give you 1. Okay, again, this is the value for sine theta for all these special angles. Now, how do you generate the values for cos? Now, you will see that if you start with 0 here, then cos ends up with 0. If you end with 1, you will need to start with 1 for cos. So what I'm hinting at is that you do the reverse order for sine in order to get the values of cos. So just reverse the order. So remember, just starting from here, you can generate the second row, and the third row. Now to get the final row, now this is a formula that you need to remember. So to get tan theta, you need to do sine theta divided by cos theta. And what does that give us for each of these values? So if you, for example, divide 0 by 1, you end up with 0. If you divide the top fraction by the bottom fraction, so you cancel out the 2, and then you end up with, that gives you with 1 over root 3. And if you multiply root 3 by over on top and root 3, so you will end up with this number. Okay, so for 45 degrees, if you divide the top fraction by the bottom fraction, they are identical, aren't they? So therefore, it gives you with a 1. And you divide the top fraction by the bottom fraction for 60 degrees, you cancel out the 2, and then you get root 3 over 1. In the end, 1 divided by 0, that is infinity, or we call it undefined. So I think by now you can replay this section. It's really important for you to be able to generate this table by yourself if you find it difficult to memorize the table. But you will get the hang of it with more and more practice. So, okay, so let's move on to trigonometry with surds. Now, in order to answer the questions that you have on your left on the screen, it would be good to have that table that you have got over here right at the top to use as a point of reference. So that will be easy. If you can't remember them, you create the table before you answer the question if you're not too used to it. Otherwise, if you're familiar with the values, it's in your head, that will be even better. So let's get started. So sine of 60 multiplied by tan of 60. So sine of 60, if you can see from the table, so that is root 3 divided by 2, and that multiplies with tan of 60. 60 is tan of 60, that gives you root 3. Or you can say root 3 over 1, that's the same idea. Now you multiply the top numbers, so that's root 3 times root 3, which is 3 over 2. So here's your answer for the first one. Now the second one, we're talking about a right angle triangle that has an angle of 45 degrees. So it is a special angle, and it has got a hypotenuse of 8 centimeters. So let's draw a right angle triangle in order to help us visualize what the shape is like. So it's a right angle triangle with a 45-degree angle over here, and the hypotenuse is 8 centimeters long. So this is your hypotenuse, and we're looking for the opposite. Now the opposite, okay, so if you remember your formula triangle, it is so, okay. Otherwise, if you remember opposite, so this is your opposite, it is always, when you're looking for the opposite, is always sine, okay, the hypotenuse multiplied by the sine of the angle. So the opposite, therefore, so the opposite of the triangle is equal to the hypotenuse. So that's the hypotenuse, sine 45 degrees, okay, and the hypotenuse is 8, and the sine of 45 from the table, it's root 2 over 2. So 8 is divided by 2 is going to give you 4. So the answer is 4 root 2. Okay, so that's the answer for the second part. Finally, work out the exact value of sine 45 squared. So I'm going to write it here. So sine 45, the value squared, and then you're going to get cos of 30 squared. As you can see from the table, sine 45 is square root of 2 over 2, which you're going to square, and cos of 30, that gives you root of 3 over 2 squared. So the first one, if you are squaring a square root, that number square root cancels out, it gives you a 2, and that was for the numerator, and for if you square the denominator, you're going to get 4. The next one, sorry, next one is square root of 3 squared, that gives you a 3, okay, and square of 2, that gives you a 4. So altogether, that's 5 over 4, or you can write it as 1/4, and here's your answer. So if you can practice that questions that I've got for you on the right hand side, okay, you can pause the video here and you will see the question appearing now. I'll see you on the next slide. So I think all your answers turn out correct according to what I've got over there for you as questions. Okay, and now it's time for us to recap. So here, these are the 3 skills that you have learned about today. We have first of all learned to multiply surd side length together to find area, expanding brackets where needed. You've also applied term and sum formula to geometric series with a surd ratio. What you've done as well is you have used the exact sine, cos, and tan values in surd form. No calculator required for these solutions. You've done really well here. So I would say well done to you. You have now covered simplifying, expanding, rationalizing, and applying surds across fractions, Pythagoras, ratio, area, series, and trigonometry calculations. So hope you enjoyed the 3 videos that I produced for you, and I'll see you on another video. Until then, it's goodbye from me.